Today we will discuss set theory. Set means collection of different objects, but they should not be repeated, non-repeated. That means collection of different objects, they should not be repeated, having some similar property, having some similar properties. That means if we take letters, then all the letters will be of the same type, like English letter, then it will be set of English letters or alphabets. If it is numbers, then the numbers should be a particular type of numbers or like that. So it is non-repeated objects or non-repeated items, and they should not be they should be having some similarity. Now when we write the sets, we write in two methods. First of all, they can be written in direct whatever the numbers are. Basically, if I am discussing the number set like 1 2 3 4, this way I can write the numbers are from 1 2 3 4 this figures. But if I write this set another way, that can be similarly x colon, x means that number which lies from 1 to 4, but x are all integers. That means from 1 to 4 all the integers are to be considered. These two are same. This is one type of presentation and representation of set, and this is another type of representation of set. Now there are many types of examples of this kind of expressions, like if we write a is equal to x colon, x means the numbers x square is less than equals to 9, where x is a prime number. Now prime numbers mean those numbers which are cannot be factorized except 1 in itself. That means we will be taking prime numbers which are whose square is less than 9, 2 and 3, because 2 square is 4 and 3 square is 9, so we have only two numbers. Because after this 2 3, the prime numbers which will be considered, that will be 5, but 5 square will be 25, so we will not take 5 in this case. So this is set builder. We consider or call this presentation as set builder. And the next one is roster method or selector method. We write the exact elements of the set. Now in the set, when we write, we have one thing, that is cardinal number. Cardinal number of the set is the size of the set. Cardinal number of a set means size of a set. Size of a set means how many elements are in the set. So if I write set of vowels, then let it be V. Then cardinal number of V will be, cardinal number of V means how many letters are vowels. That means how many elements are there in the set V, which is vowel set. We will be writing 5, as we have 5 vowels, A, E, I, O, U. This is the set V, and the number of elements of V is 5, so we can write cardinal number is 5. Now if we have no elements in a set, that is set is empty. Empty set means null set. That is null set. Null set means no elements can be or are present in the set itself. So we write empty, or we have another notation called phi, phi, phi. This is also null set, but null set does not mean this notation. This is not null set. This is not a null set. This is a set having a letter phi. If I take 0, this set is not null set. This is a singleton set. Singleton set means a set having only one element. So empty set or null set is a set having no elements, and zero set, this can be said as zero set having set and elements are all zero, only zero. So similarly, we have one more point, not similarly, we have one more point, that is universal set. This is the set which is biggest possible. Biggest possible set means the set which is the biggest possible collection of all elements of that item. We have some numbers, particular notations we used to use, that is capital N we use for natural number. So set of natural numbers means the numbers which are 1, 2, 3, that is counting numbers, and Z we denote integers. Integers means plus minus 1, plus minus 2, plus minus 3, etc., including 0. So integers include 0, but natural number does not include 0. So there is two things. In natural number set we have positive numbers 1, 2, 3, 4, and integers are positive, negative both. So one thought, all natural numbers are integers, but integers are not natural number. We say natural number is proper subset of Z. So N is proper subset. That means N is a subset. What is subset? That is, N is a set of all numbers which are present in Z, but Z, that is integer, is set of all integral values, but some more values are present in Z. So this idea, proper subset, means this set is not, this is not equal to Z. But if I have a notation A is this, then it is not proper. This is not proper. This idea is not proper subset. This means A is subset or equal to B. We don't say subset or equal to B. We say A is subset of B. So when we say proper subset, then it is not equal to possibility. Then like natural number cannot be equal to integer. And A is subset of B means A may be a set which is equal to B. Now if I count how many possible subsets are there, possible subsets of any set, include the smaller portion, include also the null set. Possible subset of any set include null set, that is empty set, and also the given set. That means if a set is given and we are asked to find out the possible subsets, we will be including the given set as well as the null set. Like we have an example, write all subsets of 1 to 5. So what we will be writing, the subsets are, only 1, only 2, only 5. That means taking one at a time. And then subsets will be 1, 2. That means 2 at a time I am taking. 1, 2, 1, 5, 2, 5. And also the given set 1 to 5 as well as the empty set. So subsets are all the smaller or equal portions of the set, including the null set. Now if you count this one, you have number of elements 3. There is a formula. How many subsets will be there? Number of subsets we have, possible number of subsets we have 2 to the power n. That means 2 to the power 3 is 8. If I count, 3 elements are there, that's why this set has n is equal to 3. Now if I count the subsets 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 subsets which comes from 2 to the power 3 also. But proper subsets, if I say proper subset, write the proper subsets of a set, then we don't take the given set. That means write the proper subset. Proper subsets of a set. Proper subsets of a set like 1, -1 or -1, 1. Then there the proper subset will be including the null set. Proper subset will be including the null set. Null set will be included, not the given set. So in the previous example, proper subsets I have not discussed. I have discussed the subset, and we have taken 2 to the power n. So number of possible proper subsets will be, it was 2 to the power n in the subsets case, but number of proper subset, number of possible proper subset will be, proper subsets will be 2 to the power n 1 less. That means here it is 2, n is 2 because 2 elements are present. So we have 2 to the power 2 minus 1, that is 3 proper subsets, 1, 2, 3. So number of proper subset will be 2 to the power n and then minus 1, and number of subsets will be 2 to the power n only. So this is a concept of subsets and proper subsets. We have another idea called power set. Power set means collection of all subsets. Collection of all subsets. That means if we write all the subsets of a set, subsets means part of a set. All the subsets of a set, if I collect together, that is called power set. So if I write a set of letters of the word pencil or pen, let it be pen. Set of letters of the word pen, then power set of this set will be only P, because P is a letter, only E, another letter is E, then N, taking one at a time, then PE taking two at a time, PN taking two at a time, NE taking two at a time, or we can write EN also. And now we will write PEN also, and also the null set, which can be represented null set as empty set or file. If I take all these together, then this is the power set. So power set means also including 2 to the power n, that is 2 to the power 3 here, because PN word has 3 letters and we are having 2 to the power 3, that is 8 possible subsets in this power set, which are the elements. So this is concept of power set. Now coming to one more notation we have that we call belongs to. Belongs to means is a member of. So if I say 2 is belonging to n, that means 2 is a natural number. But if I say half belongs to n, is not right, because half is not a natural number. So 2 is a natural number, 2 belongs to the set n is natural number set, but half is not a natural number, we will write half is not a natural number. Now coming to the set counting possible, which the set who is countable is called finite set, and the set which is not countable, not possible to count, is the uncountable set, that is infinite set. So finite and infinite set we are having. Infinite set example is n, that is natural number, or z, integer, they are infinite because we cannot count how many natural numbers are possible. But if I say set of vowels, set of like one digit prime number, set of one digit prime number. So prime numbers, there are many prime numbers which cannot be factorized except itself and 1, but one digit prime numbers are 2, 3, 5, 7. So it is countable. So when we consider this set of any particular collection, then it may be countable or it may be uncountable. So this is finite. Now we have some algebra of sets. We have more or less 3 types of algebra mainly: addition, subtraction, multiplication. 3 types. If I have a set like A, 1, 3, 7, another set is B, 2, 5, 7, then we have some algebra. First algebra, algebraic method. These are algebraic concept of set. Addition, we don't say addition, we call union. Union means A union B, and that is denoted by all the x which are belonging to A, that means the elements of the set A, or elements of set B. That means we will be taking all the elements of A, B. Union means all possible elements which are present in A or B. That means A or B means 1, 2, 3, 5, 7. So union concept means to join two sets together to get a single set. Now coming to the second algebra, this is called intersection. Intersection means intersection. This means we write this way. This notation is union and this notation is intersection. Intersection means x will be those values which are in A as well as, that is, and x are in B also. So we are having common elements. Union means all elements of A, B, but intersection means common. That means the elements who are common in A, B. In this example, we are finding that 7 is common. So A intersection B is 7. So union intersection means to join two sets or more than two sets as a single set, that is union, and to take the common elements means the intersection. Then algebra is minus or difference, that is A minus B. A minus B will be those elements of A, x are in A but x are not in B. In other words, we can say only A, set of only A, not the common elements. So if I discuss A minus B, then we will be taking 1, 3 because 7 is present in both. So similarly, if I say B minus A, then we will be taking 2, 5 because 7 is present in both the sets. So A minus B, B minus A, these ideas are the idea of union intersection means joining or taking common elements, but minus or difference means exclusive elements of A or exclusive elements of B. Now complement. The next algebra of set is complement. Complement of A means all elements of universe, all elements of universal set except A. Complement means those elements which are present in A should be excluded from the universe. Or we can say universal set, if I denote it by U minus A, that is denoted by A complement, A to the power C or A to the power dash. That means if I have an universal set as U is given as 1, 2, 3, 4, 5, 6, this is the universal set, and A is given as 1, 4, 5, then A complement will be A 1, 4, 5 we will be not taking, so which are remaining? 2, 3, 6. So this is the complement. So if I take this two union, A complement, then we will be finding the universe. But noticeable is A intersection A complement is 5. That means disjoint set. Disjoint. A and A complement cannot have any common elements. Now a very, very important rule is De Morgan's law. De Morgan's law is a very important law. This law tells us when complement is taken, then what would be happening. If I take a brief idea of the concept, then A union B whole complement, if I simplify, it will be A complement intersection B complement. That means the sign will be reversed. And on the other hand, A intersection B whole complement will be A complement union B complement. This is very important concept for De Morgan's law. Let us take an example, and for that example I am using one idea called Venn diagram. Venn diagram means drawing some diagram and trying to establish the idea. Like A is a set and B is another set. So if I draw the diagram this way, this is A intersection B. That means the common part will be represented here. This will be A minus B, only A part, and this is B minus A, only B part. Now what is happening? The whole portion is universe. We can take an example as A is a set as 1, 2, 5, B is another set as 2, 4, 5, 6, and universal set U, if I denote 1, 2, 3, 4, 5, 6, we can observe one thing, that complement of A is 3, 4, 6, whereas complement of B is 1 and 3. Now if we take the complements intersection, A complement, B complement intersection, that is intersection means the common part of these two, then we are finding 3. Now coming to this part, A union B is found to be 1, 2, 4, 5, 6. That means 3 is not present. Therefore, if I compare these two, A union B whole complement is 3, because 1, 2, 4, 5, 6 and universal set is 1, 2, 3, 4, 5, 6. So A union B whole complement will be 1, 2, 4, 5, 6. If I delete from universal set, then 3 will remain. So we have A union B whole complement is equal to A complement intersection B complement. So this way we can establish the De Morgan's law or De Morgan's rule. In this De Morgan's rule is a very important rule which is applicable in many examples. One more final idea we have in Venn diagram, the two sets, this is A, this part are all common part, that is both, and this is whole of A and this is B. So if you take A union B, this total, then total portion of A plus total portion of B, but these two, when you add, this both part, that is intersection part, should be removed. Therefore the general principles of Venn diagram, this is called Venn diagram. If you add the individual sets, the number of elements of A and number of elements of B, if you add, then the common part of the two sets should be subtracted. Like 30%, as an example, 30% are doing CA, 45% are doing like BCom, and 25% are doing both. So how many are doing CA or BCom? That means the students who are doing CA or doing BCom, this is the union part. That means CA or BCom means CA union BCom. So how many are doing, if I consider, then total CA union BCom will be number of students doing CA plus number of students doing BCom minus the students doing both is intersection. From this information, students doing CA is 30%, doing BCom is 45%, and doing both is 25%. So final result comes to actually 50% are doing CA or BCom. So this type of formulas we can apply and we can solve this type of problems using Venn diagram. Another Venn diagram, we can use other ideas also by putting the diagrams, by putting the figures or values inside the diagram. If I have three sets A, B, C, then we have the Venn diagram concept as A union B union C. This total portion will be the full portion of A, the total portion of A plus total portion of B, and then total portion of C. But this portion, that common part, is present in both A, B, so we will subtract. Then this portion B intersection C will be subtracted, and this portion C intersection A will be also subtracted. But this middle portion, which is the common part of all the three, should be added because it is not included in this total result. When you are adding, you are subtracting also. So ultimately you have to add the middle portion. I can take an example like if I have 18 students are playing cricket, 18 are playing cricket, then 20 are playing football, then 15 are playing tennis, 10 are playing cricket and football, both. That means 10 students are playing both cricket, football. Then 12 students are playing football and tennis, whereas 9 students are playing cricket as well as tennis. Now if I have one more information here, it is given, that is 5 are playing all. So how many total students are present? So if you see this one, this is A, this is B, and this is C, and this is A intersection B, because both cricket and football. This is B intersection C, that is football and tennis, and this is C intersection A or A intersection C, that is cricket and tennis, and this is A intersection B intersection C total. So when you are having the total A union B union C, that means how many are present. So we have the total number of students will be, total A is 18, B is 20, C is 15. That means it is 53 if you add, then subtracting 10, then subtracting 12 and subtracting 9, because these are the common portion, and the formula A plus B plus C minus A intersection B, B intersection C, and C intersection A comes to 31. So 53 minus 31 and plus 5. So we are getting 53 total minus 31 plus 5. So our answer will be 27. That's all for set theory, the basic ideas of this topic.